Good evening everyone. Welcome to the session Mission ISRO CS 2019-20 Champion Series. Good evening everyone. We were discussing about previous questions that have come in the past 5 years of ISRO. Right? Good evening Neha. In the last session, we have discussed already questions from 2018 ISRO paper, and if you observe the questions of 2018, we have got questions from programming and data structures. Much questions, many questions we got around, Mayuresh, good evening. Sai Bharat, good evening. Akshay, good evening. Yep. So, programming and data structures, we have got almost around 18 to 19 questions. Among them, we discussed a few questions yesterday, and if you observe on which topics the questions were, because the subject is programming and data structures. I am not talking about the subject, I am talking about the topic. From which topic they are? You found questions from basic programming, like given a loop, asking for how many times this gets executed or what would be the output of this program, kind of simple questions, right? And other, we have got questions on arrays and character array, which we call as a string. We have got question on string, and we have got questions on pointers structures. So, if you observe, ISRO is so confined, so bounded to the syllabus that they have given. That is what the syllabus, right, of programming and data structures. In programming, this is what they have given: functions, recursion, right, structures, pointers. These are what 4 concepts which you have to focus much. Okay. Anyway, without doing much delay, let us get into the session. I was just waiting for some more to add. Anyway, let's get in, guys. Okay. Shall we start? Akshay, Neha, Bharat, Mayuresh, shall we start? Ashwini, hi. Bunny, sorry, Bunty Patel, yes. Yeah, okay, let's get into the today's session. Yeah, of course, this is about me, you know already, so I am just skipping this. Yeah, it's just a reminder for you everybody. We have only 30 days left for ISRO. So, just increase the preparation time, guys. If you are preparing, let's say for 5 hours or 6 hours a day, just add more half an hour or more 1 hour from today. So, day to day, try to increase the practice time. Okay. Yeah. Shivam Singh, Rati, everybody. Good evening everybody. Okay. So, we have only 30 days, guys. So, increase the preparation time. Now, yesterday we have left few questions of 2018 due to the time constraint. So, first let us complete those 2018 questions and move on to 2017 ISRO questions. Okay, here is the first question. Of the following sorting algorithms, which has running time that is least dependent, on the initial order of input? That means in which order the elements are given, irrespective of that order, which sorting technique behave in the uniform way, right? That is what the question means. What were the options? Merge sort, insertion sort, selection sort and quick sort, right? Just to tell you guys, if you need to understand the solution or answer of this question, first you should know what is sorting, how these do or perform sorting. I believe everyone have idea. If not, first you should go through the techniques of selection, insertion, quick, merge sort and all. Then, so for those who forgot, just give me just couple of minutes of time, or just let me try to brief it very quickly. If you say selection sort, let's say there are 5 elements which are unsorted: 72, 25, 31, 42 and 15. Let's say there are 5 elements. Yeah, this is first question, Rajas. Now we need to sort in the ascending order. Let us suppose, if in the selection sort I do, what is selection sort is all about? Find out what is the least element in the list, right? 15 is the least element in the list and place it in the first position, right? So 15, 72, 25, 31, 42. Now to find 15, we have traversed all the array. Now only traverse n-1 elements. No need to do from first element in the second pass. So identify the least element in the remaining 4 elements, which is 25. So place in the second position. Identify third element, place in the third place, and so on. This is how selection sort goes on. Identifying the minimum element and placing it in the order. If you prefer insertion sort, how insertion sort goes on? How insertion sort goes on? If this is the list, 72, 25, 31, 42 and 15, we will pick one element and we will insert it in its correct position. Like if 72 is picked, it is compared with all the other elements. 72 is greater than 25, greater than 31, greater than 42, greater than 15. So what we do? We will place here, place 72 in the last position. Then we will compare the second element. I mean to tell, we will pick the other element and compare with only 4 elements. Place in the correct position. So insertion sort and selection sort looks like same, but they are little different. Okay, like selection sort make the smallest element in the first or next smallest in the next and so on. Insertion sort makes the biggest element at last in the first attempt, next biggest element in the second last. So it will give you solution in the ascending order from small to big. It will give you solution from big to small, of course in the ascending order. It will find big element first, it will find small element first. And quick sort. Generally for students, quick sort will be little typical because it's little complex procedure. Like if you pick these elements 72, 25, 31, 42 and 15, quick sort technique goes in this way. Select the first element as pivot. If this is stored in an array, their index will be from 0, and select, pick the index 1 as I, the last index as j, and move I towards right side, that means increment I, so that you should get a element which is greater than 72, and decrement j, so that you should get some element which is less than 72. So by moving I and j values, whenever I becomes greater than j, then we will say that is the correct position of pivot. This is what procedure of quick sort. If you don't have any idea about this, definitely you don't understand what I am telling. I am trying to just recall if anyone forgot the technique. And merge sort, how it goes on? 72, 25, 31, 42, 15. What merge sort do first? It will divide. It will divide the list into two halves. 72, 25, 31, 42, 15, or 3 here, 2 there, as how you write the program. This is again divided 72, 25. This is divided again into 31, 42, 15. Like this division happens until you will get one element, single element. This is divide procedure. Once a division is done, then we will compare one element with next element, then we will combine those elements in the order. This is how merge sort goes on, right? These are the techniques of sorting. Among them, which has least dependency on number of order of input. For that, I have got a table for you guys. Of course, you will get this even in the web also, as I want this to be a central source for everybody. Here I have presented the time complexity of different sorting techniques along with space complexity. Please pause this and have a screenshot of it and have it handy. At least you should remember the worst case time complexity. Worst case time complexity you should remember, if you don't remember the other. Okay? Sometimes in ISRO you will get direct question, what is the worst case time complexity of quick sort or merge sort or insertion sort or bubble sort or heap sort, different. Okay? Now, if you observe this table, insertion sort has a different time complexity in the best, worst and average case. That means if the input is already sorted, or if the input is not sorted, if the input is exactly sorted in the descending order, but now you have to sort it in the ascending order, and like this you can just assume different forms of input. One input is best case input, average case input, worst case input. So you can see there is a difference in the time. So insertion sort vary based on the order of input. Similarly, you can see quick sort. It is also taking different time in best, worst and average cases. So it also depends. Now if you observe, yeah, you can have a screenshot of it. I am moving aside for a bit. Okay. Now, selection sort and merge sort are giving uniform time, same time in all three cases. So, one is n square, other is n log n. That means we can say both selection sort and merge sort are least dependent on or independent of order of input. Now, in this, which has to be selected? Which has to be selected? Now you have to see which is small in these two, n square or n log n. Which is small? Obviously, n log n is small. How you just substitute some value for n, like n is 4. This is 16, 4 square is 16, 4 log 4. That means 4 into log 2 square, that is 4 into 2, 8. Right. So, in these two, as this is small, as we want the least dependent sorting technique, what would be the answer? Merge sort. Okay. So, what would be the answer, guys? Merge sort depends least on the order of input. Okay, next. Next question. A doubly linked list is declared as follows. We know in a linked list, node is created using self-referential structure concept. So, if anyone are not aware of that, first you better, while revising this video, you refer doubly linked list creation of a node or linked list creation of a node, so that what it means you will understand. Okay. Now, where forward and backward represent the pointers to the adjacent elements of the list, of course we know that. And which of the following segment of code deletes the node pointed to by X from the doubly linked list? If it is assumed X points to neither first nor last. Is this visible, guys? He is telling which code delete X such that X is not the first element, X is not the last element. That means it's not first, it's not last. What does it mean? It is the middle element, right? So let us see which option works out. Okay. I have just copied the same options here, option A, B, C, D. Now, let us consider one element X. This is a doubly linked list. So, doubly linked list element looks like this, which has two pointers. One is forward, other is backward. Forward, backward. Forward, backward. Forward points to the next element always, backward points to the previous element, and its backward points to null, the last element forward points to null, right? Let us suppose this is what X which you want to delete. Okay, let's say the first option. Let us consider the first option. What it is telling? X backward, forward. What is X backward? X backward means this. X backward, forward. That means its forward again is this. Right? That means previous element, next pointer. What is that? That is equal to X forward. What is X forward? This one, right? That means previous element forward should be pointing to x forward, that means x next element. Then x forward backward. What is x forward? This one, right? X forward backward. That means the next element backward. That means this one. What it should do? X backward. This is x. What is x backward? Here. So where x backward is pointing, now this should point there. That means it should be pointing to, this. That means what happened? Now let us suppose this is W, this is Y. W forward is pointing to Y. Y backward is pointing to W. Isn't it? That means these got connected. W and Y now they are adjacent. That means this is deleted. Of course, it is not deleted in the memory with that code. By writing free only, it will be erased from memory. But now it is not having any connection with W or what? Y. That means this element is deleted. You understand? In the same way, if you just analyze the other, here you see dot operator. We know whenever the structure member is pointer, we use arrow operator, not dot operator. So by looking that, you can just eliminate this option. Similarly, here you can see the dot operator. So the tie is between only these two. Like how I analyzed the first option, you analyze the last option also. You will understand. Okay? Let's move on. Sir, I don't got it. X forward, backward. Mayuresh, if this is X, let's say this is X. Okay? This is X forward, this is X backward. X forward means your next element. Your forward means next element. This is next element. Next elements backward, that is what it means. X forward backward means next element backward pointer. Okay. Similarly, X backward means where it points to previous element. It's forward, previous elements forward. Okay. Let's see the question. This is what the question. Sai Bharat. This is what the question, okay? Yeah, Mayuresh, that means X again, right? X backwards, forward. Now where it should point to, not X, X forward. That means the previous element, my previous element should point to my next element. That means I am not there. Okay? Let's move on. So what is the answer, by the way, here? The first one itself. Next, if tree 1 and tree 2 are the trees indicated below, which traversals of tree 1 and tree 2 respectively will produce the same sequence? This is the question. Before we get into the question, guys, there is error in the question, which is certified by ISRO also. That's why ISRO has not considered this question for evaluation. In the answer key, this is excluded. I hope you are getting this. As we want to solve this, let us understand what that mistake or error in this question is. Here instead of D, it should be B. Here instead of B, it should be D. Those D and B should be exchanged. Then this question is correct for the given options. Okay? Please mind this. So what is the question? Tree 1 traversal and tree 2 traversal. Which traversals will be same? We know tree traversals are basically two types. Breadth first and depth first. Breadth first traversal, depth first traversal. Okay? Depth first traversal, we have again three subtypes. They are in-order traversal, pre-order traversal, post-order traversal. In-order, pre-order, post-order. What is in-order traversal? Whenever you take a tree, let's say this is root, it will have a left subtree. Is this visible? Yeah. And it will have a right node. Let's say this is what a simple tree. Now, if it is in order, that means in indicates middle. Root should be in the middle. So in order traversal sequence should be left, root, right. Root should be in the middle. Pre-order. Pre means what? First. So root should be in the beginning. So what should be the sequence? Root, left, right. Post order. Post means last. So root should be at last, left, right. Right? Now, yes, Raviteja, you are correct. Now, let us see what traversals give. This is tree 1. Is this tree 1 visible, right? So let us quickly calculate what is in order traversal. What is in order means? Left, root, right. Now let's go on. First, left. Left is again a subtree. Go on. Is there any left for B? There is no left for B. So left is done. Left is done. Now root. So what is root? B. Then right. Right is again a subtree. Go on. Left. Left is again a subtree. Go on. Left, which is G. G is the leaf node. So left, root, which is E, right. Right is again a subtree. So go on. This is again, I is again a subtree. Means until leaf we should go on. J. J is leaf node. Right? But here if you see, I is the node which is having a right child. But what in order says? Left, root, right. So it's not having any left. Similarly, if you see H, this is again a subtree. This is the order we have to follow. Isn't it? This is the order we have to follow. So what it says? left, root is H, then right, then right. Again, I has no left node. Left root is I, then right, which is J. You understand? So all this is over. Left for D is over. Now root, which is D. Right, which is F. Now left is over, B is over, right is over. Now the ultimate root A, then C. This is in order traversal. Similarly, what is a pre-order traversal? Pre says left, root, left, right. So, yeah. What is pre-order traversal? Anybody? Root is A, left is subtree, again root first, there is no left. Now right is again subtree, root first, left is again a subtree, root first, left, G, then H, yeah. So root, left, right, root, left is again subtree, so root, left, G, now right is again a subtree, in this again root, which is H, there is no left, right it should go, it is again a subtree, so root, left, there is no left for I, now J, now all the left is over for D, root, left, right, yeah, someone is telling A, B, D, E, G, H, I, J, F, C, right. Similarly, what is post order? Quickly, I am doing for this, right? Somebody can help us with the in order, pre-order, post order traversals of tree 2. Quickly guys. Definitely your help will be appreciated. Yeah, Mayuresh, G, J, I, H, E, F, D, B, C, A. Right. Now, tree 2 in order, pre-order, post order I want. Please don't forget to exchange this. Here B, here D. Now you calculate in order, pre-order. Yes. Sirisha, is that after exchanging B and D? Raviteja, Sirisha, is that after exchanging B and D? So what is in order says? Left, root. So that should be A, D, B, right? Raviteja, for the second in order is that? It cannot be BD, it should be DB. Vandan. So I am getting different answers. So please hold, let me do it for you. This is the tree. In order says left, root, right. There is no left for G. Left is over. Root is G. Now right. Right is again a subtree. Left is subtree. Left is subtree. Again left is subtree. Left. Now J, I, H, now E, F, D, B, C, A. Yep. Pradeep, you are correct. Good. Sandhya Bharti, Yes, you are also correct. Good, good. I want pre-order and post-order, please. Pre-order and post-order. What are pre-order? What are post-order? Post-order or pre-order? Yeah, Sirisha, that's okay. You have exchange. You exchange now and tell me pre-order and post-order. Quick, guys. In ISRO, time matters a lot, right? You should be accurate as well as quick. Mayuresh, let me put pre-order is what? GFE, IJH, CBDA. Okay. And what is post order? What is post order? Pre-order GFE, IJH, CBDA. Yes, I have written post order, please. JHIE, DBA, CFG. Okay. DBA, CFG. Fine. Now you please compare. All are here. What and what are same? You can see these two. Post order of tree 1, in order of tree 2. They are same, right? So, post order of tree 1, in order of tree 2 are equivalent. That is the answer. Anyone have confusion? You can just replay this after the session and you try solving with your own examples, because those who don't have idea about it, they don't just understand with one way or with one attempt. As much as you practice, that much perfect you will be, that much less time you can take. Those who are giving the answers, very good. I appreciate you all. Very good. But don't neglect this as you feel like you got it. You should practice much because it kills your time. You can see it is taking almost around 5 to 10 minutes of our time. But in the ISRO, you are not supposed to take 5 or 10 minutes for any question. You should do it within 2 minutes. Within 2 minutes, remember. For any question, don't take more than 2 minutes. That is maximum, I am telling. Because only 90 minutes you have. So, practice this. And this kind of questions you got many. So, definitely you can expect there is much probability for this model to come. Keep practicing. Okay? Let's move on. The number of structurally different possible binary trees with 4 nodes. How many different binary trees are possible if there are 4 nodes? Here you should understand one point. First you should know what is binary tree. What is a binary tree? A tree which has 0 or 1 or 2 children, right? For every node there should be either 0 or 1 or 2 children. That is called what? Binary tree, right? Sandeep Reddy, you try to revise by replaying the video. I understand your problem. You are feeling little difficult in the post order. I request you to just try to get it done by yourself once. If not maybe at the end of the class we will see. Okay, Sandeep? Let's move on. Okay? Yeah. Here we should understand one point, guys. Whenever we say binary tree, when we understand binary tree, we have different types of trees like complete binary tree, strict binary tree. Similarly, we have AVL tree, we have binary search tree, we have red black tree, we have B tree, B plus tree. Like this we have so many to discuss, so many to know. So at this time, understanding about every tree, solving every tree questions, it is really not suggestible. But what I recommend you is, in trees especially in our computer science, for programming and data structures, for trees we have set of formula. Set of formula we have. On Saturday I will give you those important formula for programming and data structures. Please remember those formula so that it will be very easy. It won't take much time. Okay? Yeah, Sirisha was telling 336, Shivam Singh 14, okay, and Sai Bharat 4 factorial, right. So here what I would like to tell is, whenever it is given like this, first we should know, is the nodes are labeled nodes or unlabeled nodes. What is labeled? Whenever a node is assigned with value, a node has value, that is called labeled. Value, or you can say some character, some name, like A, B, C, or 15, 12, 18. So if you observe, in the node we have some value or there is a name for the node. This is called labeled. Unlabeled. What is unlabeled means? Simply, there is no value or no name for the node. But how many nodes means? There are 3 nodes. Like that. So we should first know, is it labeled or unlabeled? Sir, it is not given in the question, labeled or unlabeled. So what to be taken for default? When it is not given, unlabeled becomes default. So here I am giving you 2 formula for this question. Please make a note or take a screenshot of it. In the same way, I will give all formulas of programming and data structures. You can treat them as the shortcuts. So I will try to present the tips or formula on Saturday class. Okay? So here we have formula. If it is a labeled node, if it is labeled, then how many binary trees are possible with n nodes? 2n factorial by n plus 1 factorial. Okay? And if it is unlabeled, then 2n factorial by n plus 1 factorial into n factorial. If you have a little more understanding of mathematics, you can straight away say this is what? Catalan number. Nth Catalan number we will calculate in this way, with this formula. Okay? The derivation or explanation for this formula is there. If you want that, you can go through. But I believe the derivation or how you got it, etc., at this time, because we have only 30 days of time, don't go into details. So please remember, if it is labeled, it will be given in the question. If nothing is given, by default it will be unlabeled. Yes. Yeah, Bhanu, by default it will be unlabeled. So, what is n value given? 4. So, let us quickly calculate. 2 into 4, 8 factorial divided by n plus 1, 4 plus 1, 5 factorial into 4 factorial, isn't it? So we can write this as 8 into 7 into 6 into 5 factorial divided by 5 factorial into 4 factorial. 5 factorial goes on. Now, what is 4 factorial? Straight away I am writing 24. Okay. So we know 6 goes 4 times, 4 goes 2 times. So what is this value? 14. Okay. Shubhasri, thank you. These two formula you remember. Similarly, regarding height of a tree, level of a tree, depth of a tree, especially tree, we have some. Yeah, Shivam, recurrence relation, definitely that's the part of algorithms. Once data structures is completed, algorithms we will discuss. In that I will show you how to solve the recurrence relation. Okay, Shivam? Yeah, please go, just refer our Mission ISRO schedule when the algorithm class is, according to the schedule that will go on. Okay. Let's move on, guys. The next question, what it is? In a compact 1D array representation for lower triangular matrix, okay, lower triangular matrix. Guys, you know what is lower triangular, upper triangular and all? Okay. All elements above diagonal are 0 of size n by n. Non-zero elements of each row are stored one after another. Starting from first row, the index of ijth element in this new representation is. Okay. Let us try to understand this, guys. What it is? Let's suppose n by n, let n is equal to 3. So let us suppose a 3 by 3 matrix. Okay. 3 rows, 3 columns. Now, what becomes the lower triangular? Right. This becomes the lower triangle. All the elements above diagonal are 0. That is given in the question. Now, we know in the matrix for programming, we use I for row, j for column generally, and we know the index starts with 0. Okay. Now, let us assume some values for this. Let's say this is 11, 20, 30, 40, 50, 60. Now you should store only lower triangular matrix values in the array, 1D array. So this is what 1D array. How this has to be stored? 11, 20, 30, 40, 50, 60. This is how you have to store them. Okay. Now what would be these indices? 0, 1, 2, 3, 4, 5. The question is that if I want 0th element 11 index in the array, if I want 2, 1, a of 2, 1 is what? 2, 1, 50 index in the array, how do you get that? That is the question. Did you understand the question? Yeah, Pradeep, it is j plus I into I minus 1 by 2. Yes, that is correct, Pradeep. How that is? Simple. The number of elements in previous rows. How many elements are there in the previous row? That means if you want index for some a of I comma j, here which represents row, I or j? I, right? So number of elements in the previous row for I, that means I minus 1 rows plus j value. Plus j value. Let's see. First, what is A of 0, 0? A of 0, 0 index I want. Are there any more rows before this row? No. So, number of elements in the previous rows are 0 plus, what is j here? 0. So, what is the index of this? What is the index of this? 0, isn't it? The first element index. The first element index in this array is 0. Correct? Similarly, you just do this with some next element. So, this would be A of 0, 1. What this is? This is what? Not A of 0, 1, sorry. A of 1, 0. First row, 0, first column. Sorry, second row, first column. So, in this lower triangular matrix, now I is 1. In the previous row, how many elements are there? 1. So, what it is? How many elements? 1. This is not I value. How many elements in the previous rows? 1 plus what is j? 0. So, that is 1. Similarly, what would be A of 1, 1 index? In the previous row, 1 element is there. And what is the j value? 1. This is 2. What is the next element? A of 2, 0. Right? The next element is 40. Whose A of ij means A of 2, 0. So, what would be this? Before this, how many elements are there? Before this row, how many elements are there? 1, 2, 3 elements. Right? 1 element, 2 elements in the second row. So, before this row, how many elements are there? 3 elements plus what is j value? 0. A of 2, 1. Before these 3 elements, j value is 1. A of 2, 2. Before these 3 elements, A of j value is 2. So, which is 5. So, do you got the indices 0, 1, 2, 3, 4, 5? So, how you are getting this? J plus how many elements in the previous rows? If it is the first row, you will not have any element, 0. If it is a second row, you have 1 element, isn't it? If it is next, you have how many? 2, second row. Third row, 3 elements. Fourth row, 4 elements. Like this, right? That is what diagonal matrix, triangular matrix. 1 element, 2 elements, 3 elements. If you assume 4 by 4, 5 by 5 matrix, 4 elements, 5 elements, like that it goes on. So, if you just see this, this is what a natural series. If you have n elements, it goes so on to n. So, what is this? J plus 0 plus I into I minus 1 by 2. So, this is j plus I into I minus 1 by 2. What Pradeep was telling is correct. Okay? Did you get this, guys? Right. Let's move on. Yes. Which of the following permutation can be obtained in the same order using a stack, assuming that input is the sequence 5, 6, 7, 8, 9 in that order. 5, 6, 7, 8, 9. Input is given in this order, then which of the sequence is possible? This is a stack. What is a stack? Last in first out list. So if you suppose if you have given all the elements, we say push all 5 elements one after the other, then how the stack would be? 5, 6, 7, 8, 9. Now, if you want to access these elements, you can access in the reverse order only, isn't it? So, how you can do that? 9, you have to pop 9 first, then 8 and so on. So, what is one way you can access the elements? 9, 8, 7, 6, 5. Check out, do you have that sequence? This is one possible sequence to access the elements. 9, 8, 7, 5, 6. Is that? No. You cannot access 5 before 6. Is it that? You can't access 5 before 6. How that is possible? Because this is stack. So, this is wrong. Next, let us apply this. 7, 8, 9, 5, 6. When this can be possible, guys? Let's say you are pushing 5, then 6, then 7. 7, if you need to get 7 first, what you have to do? As and when you push 7, pop 7. So, 7 you got. Okay. Now, push 8, pop 8. Similarly, push 9, pop 9. So, 7, 8, 9. This order you can do in this way. Push 7, pop 7. Similarly, push 8, pop 8. Push 9, pop 9 after 5 and 6. Okay. Now, once these are popped, what is there? 6 and 5. What you can get first? 5 or 6? 6 you can get first. Then 5. Right. So, 7, 8, 9, 6, 5 is possible sequence. 7, 8, 9, 5, 6. No. 5 you can't get before 6. Because input is given in this order. Don't forget that. Similarly, if input is given in this order, 5, 6, 7, 8, 9, let us say 5 you have pushed, then popped. So, 5 you got first. Then, what you will push after 5? 6, 7, 8, 9, right? So, 6, 7, 8, 9. Let's say 9 you got, 9 you popped. For the second option I am telling, 9 you popped. Now, what is there? 8. So, without popping 8, how you can get 6 or 7? So, that is not possible, right? So, if you are pushing, you should push in this order only. This is what the input. Pop you can do in any order. So, which order of popping is valid? That is the question. So, we have tried. This is giving 7, 8, 9, 6, 5 as the valid sequence. Yes, Pradeep, you are correct. Good. Good, everybody. Sandhya, Pavan, Vineet, Kirti, and Sirisha, Monica. Yes, good. Mayuresh, everybody. I appreciate you all. Let us move on. A binary search tree is used to locate the number. By the way, we have finished 2018 questions. We have switched to 2017 questions. Mind that. Okay. A binary search tree is used to locate the number 43. Which one of the following probe sequence is not possible? Here probing means you can simply say you are trying to search it, you are trying to find. Then in which sequence you cannot get 43? This is a very frequently asked model in ISRO as well as in GATE also with probe sequence. So pay attention guys, pay attention. I'll tell you first what is binary search tree. If you have a node, let's say X, then all left elements should be less than X, all right elements should be greater than X, isn't it? This is what binary search tree means. So let us construct this sequence as BST one by one. I will show for one. 61 we have taken, we want 43. So until you reach 43 you should go. 52, it is small than 61, so we will write it as left subtree. 14 which is small, 17 is small, sorry 17 is big than 14, 40 is big than 17, 43, yes this is bigger. Observe all the left subtree, all elements are less than 61, right? Next, all elements of are less than 52. So than parent, greater element cannot be on the left side. Yes, that is holding good. Like that, if you see, you try for B and C. It's not option C. The answer is option D. Okay, do you want me to try for B or C? Okay. Let me do first option D. 17, next element 77 is bigger, so mark it as right. 27 small, 66 bigger, 18 small, but you observe here you got conflict. We are drawing a right subtree for 27. What should be there on the right? Greater elements, isn't it? Big elements than the parent, than the root, big element should be there. But 18 is small element. 18 is a small element. So the conflict is between 18 and 27. So this probe sequence is not valid because it is not giving you a BST. Understood? Sir, if the question asked for different probe sequence possible for searching 43, then how will we do it? Shivam, with these options, if the question is asked, as you are telling what are different probe sequences, then by giving these sequence 1, 2, 3, 4, then you will be having options as 1 and 2, 1 and 3, 2 and 3, etc. Okay? Yeah. Shivam, Shubhasri, so you want me to repeat again? Okay, please focus. We want a binary search tree. Binary search tree means left node should be less, right node should be greater than parent. It should satisfy everywhere. As you go on at any level, that property should get satisfied. Okay? That means all left elements should be less than the parent, all right elements should be greater than the parent. Now, I am trying to draw for first option. 61 is the parent I took, because this is the sequence. In this sequence, can we get BST? Can we reach 43 or not? That is what we want to find. So 61 I took. 52, which is smaller than 61, so I took it as a left child. Small element should be left. 14 is small than 52, so I took it again as left. 17 is big than 14, so I took it as right to this. While this you observe, it is not only greater than 14, it is less than 52 also, because it is left side of 52, so it should be less. 40, yes, it is less than 52. 43 less than 52. 52 less than 61. So all the left elements are less than the parent. Like that, if you try for fourth option, 77 bigger, so I took it as right. 27, which is small, 27 is smaller than 77, 27 is bigger than 17. It is bigger than 17 as well as smaller than 77. So property holds good. 66, yes, 66 is smaller than 77, 66 is greater than 17, 66 is greater than 27. So to whom it is left? To whom it is left? It should be small value than that. To whom it is right? It should be big value than that. Like that, 66 satisfied. Now 18 if you take, 18 is less than its parent 66. But what is 18's grandparent? 27. Right? It is towards what side of grandparent? Right side. That means 18 should be greater than 27. Is it? No. So it is not forming a valid binary search tree. So this is sequence can't locate the number 43. Here itself it stop. If you do this input for a program, with 18 itself it will stop. It can't locate 43. Okay? Now, next question. The characters of the string KRPCSNYTJM are inserted into hash table. No, Shubhasri, it's not at all trouble for me. It's my job. I am happy that you people were active in the class. You people were asking to repeat. No, I am very happy for that. Don't worry. Keep asking doubts whenever you don't understand. Okay? Yeah, Pawan, is these questions are relatively easy than GATE? Yes? Don't you feel that? But the thing is, you have less time than GATE. Questions will be easy than GATE, but time will be less than GATE. That is the challenge. Okay? Yeah. Hash function is given. H of x is something. If linear probing is used to resolve collisions, then the following insertion causes collision. Let us analyze this. Today I came with all the things, all the stuff ready. Yeah. Probing is something like tracing, chasing. You want to chase 43, you want to reach 43, you want to reach 43. Then how you will do that? Here also you see, this is the sequence we got, KRPCSNYTJM, and this is the function then which gives you collision. What is the hash function? How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are there. 10 inputs are there. So let us take a hash table of size 10. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay. We know indexing starts with 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, whenever you store this in the hash table, which will be stored? How do we know? According to this function. Okay. Here I have written the numbering for the letters. Linear probing. That means in the order. A, it's the first number. B, second. C, third, and so on. Z will be 26th letter. Right? So, for easy access, I have presented here. Now, let us calculate h of k. That means in the hash table, what is the index of k? First one. How to calculate? That is order of k minus order of letter A. What is the order of letter A always? 1 plus 1. Order of A, this is always 1 because that is the first character. It is always 1. So minus 1 plus 1 gets cancelled. So what is the function you can simplify? H of x is order of x. So h of k is order of k. What is k? 11 modulus 10. Modulus 10. So 11 modulus 10. Modulus gives you remainder. What is this? 1. So k should be here. Similarly, h of r 18. 18 mod 10. Because plus 1 minus 1 gets cancelled. That's why I am not, again, every time I am not taking it. Okay. 18 mod 10, which is 8. So what is that? R. Then h of p. H of p. P is 16. 16 mod 10. 6. Like this, if you do for C, 3 mod 10. 3. Directly writing. Then S. S mod 10. 19 mod 10. Then N. N mod 10. 14 mod 10. Then Y. Y mod 10. 25 mod 10. 5. Then T. T mod 10. 20 mod 10. 0. Right? Then J. What is J? 10. 10 mod 10. 0. So it also should be in the 0. Then H of M. M 13. 13 mod 10. 3. Already in 3 we have something. So in this probe, which is giving you collision? J and M. These are giving you collision. Let us see which is there in the options. Y is not, C is not, P is not, J, M. Even if J is there, that would be the answer. Yeah, Vineet, what is asked? Which gives you collision? Which of the following insertion causes collision? Okay? Why are we not adding 1 plus 1 and then subtracting it from order of x? What is order of A? Order of A is what? 1. Right? Order of A is what? 1. Minus, it is not. Please observe. This is order of x minus order of A plus 1. Minus 1 plus 1. How that could be 1 plus 1? That is minus 1 plus 1. Neha Singh. Did you get it? Order of x. What is order of x? If x is A, what is its order? 1. If x is H, what is its order? 8. That is what order of x. Did you understand? Okay, let's move on. Suppose the numbers are inserted in that order into an initially empty binary search tree. The binary search tree uses the reversal ordering on natural numbers. 9 is assumed to be smallest, 0 is assumed to be largest. Here we should understand 9 is the smallest element, smallest number, 0 is the longest or largest number. Vineet, if total number of collision have asked, then total number would be 4. Please help. Yeah, Vineet, collision means if already something exists, then when a new thing comes and hit it, that is called collision. So, just a minute students, we will just see the previous slide once. Here, M is causing collision with C. Similarly, J is causing collision with T. So, the number of collisions will be 2, not 4. Is that fine, Vineet? Only 2, not 4. Because while you save C, there is no collision. While saving C, there is no collision. While saving T, there is no collision. Okay? Yeah. So, here it is again a BST, binary search tree question. 9 should be small, 0 should be large. Now, what we want? The in-order traversal of the resultant binary search tree. Always remember, in-order traversal will be in the sorted order, that too in ascending. Always, this is the small trick you need not to do. Yes, yes Pradeep, you are correct. So, in order will be always giving you the result in ascending order. Here, ascending means small to big. Here, what is small? 9 is small. So we have to consider in reverse. So what will be the ascending sequence according to this question? 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Because 9 is smallest, 0 is biggest. Okay? Did you get this? Yeah. Next, a priority queue is implemented as a max heap. This is a question from heap tree. Yes, Rajan Jain, thank you sir, always want this type of live sessions. Definitely, Jain, we are here for that. Keep attending the sessions regularly so that it enhance your skills. You will get very good score in ISRO as well as in GATE. Okay? Max heap. Initially it has 5 elements. The level order traversal is 10, 8, 5, 3, 2. The level order traversal. Guys, for heap we require much prerequisite knowledge. So I don't give all the information about heap, but I can brief. Suppose this is the heap tree I am drawing. 10, 7, 2, 6, 3, 5, 4, something I have taken. Whenever you save this, how do you save means 10, 7, 2, 6, 3, 5, 4. Heap index starts with 1, remember, it's not with 0, it's not with 0. So, if it is at, what is its index? 10 index is what? 1. Then its left element index would be 2n, right element index would be 2n plus 1. If the parent index is n, left child index would be 2n, right child index should be 2n plus 1. You check this whether it holds good or not. Always it holds good. Now what it is given? 10, 8, 5, 3, 2. So, ten, 8, 5, 3, 2. What could be the maximum heap tree for this? Just you write the indices, you will get which is parent, which is child. 1, 2, 3, 4, 5. So if this is n, which is having at 2 into 1 index? 8. So that would be left one, because n is 1. 2n means second index element. 2n plus 1. Third index element will be right one. Now, n is 2. Which is having at fourth index? 3. So that would be its left child. 2n plus 1, 5, fifth index, that would be this. So according to this rule, the left should be at 2n index, right should be at 2n plus 1 index. According to this rule, we have constructed the maximum heap. What is the max heap? The parent is always greater than children. Parent should be always greater than children. All children, it's not left or right, all children. See, 10 is greater than all the children. 8 is greater than all its children. Like that. Okay? Now, what we do? Two new elements 1 and 7 are inserted into the heap. then the level order traversal. Level order traversal means breadth first traversal. Okay. So, for this, insert 1 first. Where you have to insert 1? Always when the size is n, for the insertion starts at n by 2 index or x by 2 index, where x is number of elements. So you will start probing at x by 2. What is x? Number of elements. How many elements? 5. So 5 by 2. We have to take the ceiling, the lower one, integer division we have to do. So 5 by 2 gives you 2. So what is there at second index? Two. Right. So now wait a minute. So insertion starts at x by 2. Even you can take x plus 1 by 2 probing. X plus 1 by 2 also you can take. That would give you 6 by 2, 3. Just to be simple, I am changing it. X by 2 is only valid. You can take x plus 1 by 2 also. That means where to start? Here if you take 1, it is 1 is what we have to insert? First 1. Where you can insert it? Here. So is this satisfying every property? All children are smaller than parent? Yes. Now insert 7. Where you insert 7? Here there will be 1. That means it is giving you the index 6. So 6 by 2, 3. That is how I have written. Okay. So forget about all this. Now just now 7 I should insert. Where I have to insert first? It is coming at index 7. Right. So initially I insert here. But if you observe, 7 is big element than 5. So children can't be larger than parent. So what you have to do? Swap, exchange. 5 here, 7 here. Okay. Now is 7 bigger than 1 and 5? Yes. Is 7 smaller than 10? Yes. So this is what happens. Now what would be the level order traversal? Level by level. 10, 8, 7, 3, 2, 1, 5. Okay. 10, 8, 7, 3, 2, 1, 5. 10, 8, 7, 3, 2, 1, 5. Yes, you are all correct. Option D. Did you understand? The minimum number of stacks needed to implement the queue. It is a straight simple question. 2. To implement the queue, how many minimum stacks are required means 2 stacks are required. It is straight question. Okay, how to implement and all, you please Google it and see if you want more details. Okay. Next, what is the maximum height of any AVL tree with 7 nodes? Assume that the height of tree with single node is 0. Okay. Now, AVL tree. Again, it is a binary search tree. What is AVL tree means? It should satisfy some properties like it should be a binary search tree, no duplication, and the first and foremost, the main property is of AVL tree is the height of left subtree minus the height of right subtree can be either -1 or 0 or 1. You take at any node, its left node's height, right node's height, difference should be either -1 or 0 or 1. This is what we call as balancing factor. Yes, Sandhya, as you said, you are correct. AVL tree is also called height balanced tree. Exactly, height balanced tree. Okay, so what it is? So if by satisfying those properties, if you take 7 nodes, something like this, D, E, F, wait a minute. So you will get some AVL tree like this. Sir, how did you draw? Means I am just making sure the left and right heights should not be more than 1. The difference should not be more than 1. So this is one of the possibility. You can draw like this. So if you see the height, it is at height 0, height 1, height 2, height 3. So what is the height of the tree with the 7 nodes means? What? 3. The in-order and pre-order traversal of binary tree. Guys, I am leaving this for your practice. We have already discussed about this in-order, pre-order traversal. I am leaving it for your practice. Okay. Let me give you the answer for that. What is the answer? This is the answer. You verify it. Okay. You try it, guys. Let us move on. Which one of the following are essential features of object-oriented language? OOPS principles. Again, this is a straight question, simple question. Abstraction, encapsulation, polymorphism. Yes, these two are the essential features of object-oriented language. We do have other, right? OOPS features, inheritance, encapsulation, polymorphism, abstraction, dynamic binding, class, object. So all OOPS principles are essential features. So you can say A and D only. These are the essential features of object-oriented language. Okay, fine. I think it's already 8 o'clock. Type safe property coupled with subtype rule. This is related to typecasting. Type safe property is related to typecasting. Means whenever we are narrowing any data, in order to avoid losing the data, this constraint is there, type safe property. So that is related to typecasting. Sirisha, you please refer that. Okay. Yeah, we will conclude the class with this. Okay, we will continue the session tomorrow. We have a couple of questions from 2017. Once we discuss that, we will go to 2016 gate questions, ISRO questions. Okay. Yeah. Sir, does strictly typed related to statically typed languages where the data type has to mention? They are related, Shreyas, what strictly typed and static type checking, loosely typed, dynamic type checking. They are related but not same. Okay. Okay. Anyway, guys, today I just want to end up with one thing, that is, yeah, regarding this, you can write more and more mock exams. You can get access to all the mock exams from our Gradeup green card. I think you know it already. Why I am specific is because from tomorrow it is going to be increase the price of green card. Till today it is 399. Today it ends. This offer ends today. So from tomorrow it is going to be 499. So just circulate this to your community, your friends, whoever are serious. Because just for 399 you can get access to many mock exams, topic exams, all kind of exams. So don't lose this opportunity. From tomorrow it is going to increase. So that is what I would like to convey. So guys, we will continue the session tomorrow in the same time, 6:30 p.m. So keep practicing, guys. Prep smart, score better, go grade up.